Okay. So I don't have an agenda for the meeting today. I just basically wanted to give everyone an opportunity to give a status update or discuss anything. Um, I've got a few updates. I know Court has some, and I'm interested to see how things are going with you, Alistair. So, um, Court, would you like to start?
Yeah, I'll start. Um, so I've got two items. Hopefully you saw a post that I made um, to the Signal chat. Um, I I have a running um, bot that has a tiny improvement, and so I took the opportunity to um, make the model diff as small as it possibly could be, and I've got a pull request with that model change in it, and it's a minor diff between the base uh, random move robot, and then it adds a strategy that changes the behavior of the bot. And my first reason for posting it was simply that, so that anyone coming behind me who wants to begin making a change to the model, they can look at that pull request and see the smallest, exactly where you would go to make a tiny change and, begin changing the behavior. And what the change is I added a package called move selection, and I put a function in there, and I intend to maybe put more functions in there, but I've got one function in there called simple max advance, and that function gets called from the state where Levi's teacher robot is just selecting a random move. I actually even left that in place, and so the random move gets selected, but then a call gets made to simple max advance, where different criteria are applied to making the move, and tested it. I did a couple of other things to make sure that the diff was small. I updated main with the persistence indentation, made to be consistent, and then posted my PR against that updated main. It's also kind of fun. It was an idea that when Levi first was talking about a chess challenge, I was thinking of just simple move selections that would be interesting. And what this one does is it looks through the entire list of moves and maximizes, is it rank?
Yeah.
So it maximizes, basically your forward distance. And so it's kind of it's simplistic, but it's aggressive, and it's kind of fun to watch. And so far, that bot has never lost against the random move selection bot, although it does get in a stalemate sometimes. Um, uh, and so that's the second purpose, is just I wanted to see what that simple algorithm would do, and have some material that could go into a presentation for the conference. But the primary reason was to make this pull request easy for other people to see and follow on, even though I know some of you have already been, are well past this right now. Any comments, questions on simple max advance?
Just a question on the general. I've watched yours run through, and what slightly surprised me was both it's presumably that video, the sort of one you can play through, that's playing your simple max advance against the random one. Is that right?
Correct.
So even in the random one, it seems to take pieces more often than I thought it would randomly. Is it prioritizing at all, or is it just genuinely random? Because it was taking pieces quite regularly, and I thought if it was truly random, it would go off in the other direction or something.
I think that's a coincidence because
Okay,
if you look at the action language, it's not truly random, but it takes the um, smallest digit of the current clock and indexes into the list of legal moves, based on just the last digit of time.
right.
So it doesn't even try to detect whether it's a take or not. I will say that my simple max advance, um, I am I'd made one change beyond just simple max advance because um, with my first version, the pieces would march forward and then they'd get up against the other end of the board and then just kind of jiggle sideways. Um, and so I changed it such that if I can't go forward, then I select a random uh, move.
Right.
Um, and watching it run several different times, it does sometimes look like the board just got turned around because all of my pieces are on that side, and then the random guy is milling around in the middle. Um, the README, I think since our last meeting, the README has been updated to include um, how to get two bots running against each other. Because it gets a little tiring to, play against your own bot or play against someone else's bot when you really just want to see the behavior of your own bot. Um, and so it's really nice to put your own bot against the random bot. There's also Levi has on a Linux machine in his home, he's got his kind of not current best, but a decent look, 4 half moves into the future,
Three, actually.
three half moves into the future, and it's running all the time. You can challenge that bot at any time. And 3 half moves into the future beats me as a person. Um, and 4 half moves into the future beats Levi. Has Ezra played against your bot much?
No. I should have him try.
Yeah, that's another try.
It would be interesting to have it play against Stockfish at various levels.
Yeah, I've thought about doing that, and I've even thought about potentially creating a component or something like that that I can add to the model that allows you to test your implementation against Stockfish. Um, Unfortunately, Lichess has the ability to play for you as a user to play against Stockfish, but it doesn't have it registered as a bot user in the same way that my bot is registered as a bot user. And so um, there's not a way right now to do that.
Before I give the second half of my update, Levi, why don't you talk about your, um, kind of at, at lunch when Keith, and I had lunch, you described your
My current state of implementation.
current, yeah, and looking into the future as far as you can. The asynchronous nature
Yeah.
is an important point before, I talk about MC 3020.
Yeah, so I think I mentioned this in the last meeting, and I haven't done that much since the last meeting, but I've been focusing a lot on the part that's interesting to me, which is the graph search aspect of things. And so at the moment, my implementation, the way it works is as soon as the game starts, the evaluation engine kicks off and starts evaluating future positions. And it creates a tree essentially of positions where the nodes are the state of the board and the edges are the moves that lead to that state of the board. So it creates a directed graph. And it performs a depth first search at a specific depth. So say 2 half moves into the future. So I play and then my opponent responds. Um, and it will search to depth 2 and find a move and decide how good that position is based on, at the moment, it's just basically counting up the pieces and weighting them based on how valuable they are and taking the difference between your pieces and the opponent's pieces and using that to determine how good the position is.
What's the technical term for that?
Material count.
Material count.
Yeah. So it takes the material count into account. So it searches depth 2, and then it goes back and searches to the next branch in the tree and does this depth first search. And as it goes, at each level, it will replace the current best branch with the previous one. And then by the end of the entire depth first search, it has the best, what it thinks is the best sequence of moves 2 into the future. And there's some graph pruning stuff that it does so that it can cut down some of the searching that it has to do. So there's certain scenarios in which you can be reasonably confident that a branch is not interesting, and so it can discard those branches. And then once it's completed a full run through at depth 2, then it bumps it up to depth 3 and goes again. And the only difference when it goes through depth 3 is it already has a set of evaluations for each branch. So it knows which one it thinks is the best path. And the pruning algorithm works the most efficiently when you evaluate the best moves first. So once you've gotten through depth 2, that actually improves the efficiency of the depth 3 search because you already have kind of an initial prediction for the ordering of the moves. And then when you get through depth 3, you go to depth 4 and so on. So it incrementally deepens this search tree. And at the moment, I'm running to a max depth of 5, I think. And it takes about 10 seconds of evaluation to get to depth 5. And as this is happening,
That's running the Sierra Java compiled version on an Apple laptop.
yeah. It's about, and it seems to be about the same on my Linux server at home. So I think some of the inefficiencies aren't necessarily compute oriented. Uh, Maybe, I don't know. I haven't explored too deeply into that. But anyways, as this is going on in kind of the background all the time, there's a timer in the foreground that decides when it's time to play a move. So at the moment, my time management is as simple as give me a set number of seconds per move. So 3 seconds, 5 seconds, 10 seconds. And at the end of that time, go to the tree and say, okay, what is your current guess for the best move? Go ahead and play it. And then everything gets updated. The tree gets pruned with paths that weren't taken, and it continues to build the depth back to where it reaches to the maximum depth that's configured. So depth 5 at the moment. And the reason there's a maximum depth is because of memory usage. So at certain level, it gets so slow because it's using so much memory. So there's improvements to be made with that. But it's I have more work to do to kind of make the time management part smarter. So deciding when it's appropriate to use more time or less time, because at the moment it's just a fixed set of time for each move. And it does think while the other player is playing. So
So when the other player plays, you that basically shrinks your tree. You can prune a load of things out of the tree when that happens.
right. So everything that is a path that didn't get taken gets removed when the game gets updated. But while the bot is waiting for the other player to think about their play, it's still thinking about the future paths.
It doesn't get distracted with while the other players.
So yeah, so if you sit there and let it think while if you take a long time to move, it reduces the amount of time it needs to get a good guess on when it becomes its next move.
Right.
Levi, you also noted that for each half move, if you're in the middle of deciding, let's say you've got a tree that's got three half moves done, and you're now searching at depth 4 until you get done with all of the moves at depth 4. You very likely don't have a good move. You're better off playing the best move from the end of a complete search.
Yeah, yeah. So I ran into that issue where I thought originally that it would be best. So say I get through, like Court said, 3 half moves, and then I'm halfway through the search of 4 half moves. My thought was that's probably a better move already than the one that I found with depth 3. But it turns out it's not exactly the case, because if you think about it, 3 half moves is me, opponent, me again. And so oftentimes what you find with the odd numbered steps is that you might take a piece and feel really good about yourself, but you're about to get taken right back. So maybe you take a pawn with your queen, and the very next move, your queen gets nuked by some other piece. And so from the perspective of depth 3, that seems like a really prudent move, but when you get into depth 4, it's not so much.
Right. Yeah.
So then an experiment that I'm not sure I'm going to do, but I'm still evaluating how much work there is to be done. And that is, I want to play, we can already do it with running a bot that's playing in verifier against a bot that's got compiled Java code. But verifier is, to to put it simply, verifier is just so slow that it can't look into the future very far at all. And so there's almost no point in running verifier against Java compiled code. But it might be interesting to take a relatively sophisticated algorithm like Levi's building that does depend, has, compute capacity is an issue. And so what I want to do is try to bring MC3020 up to where it can compile the LeechS interface and so that I can generate C code and compile it. And then I want to take the same bot and run it as a C application, as a Java application against each other, and just record the results and be able to report the findings. There's a couple of possibilities. First possibility is that the C code is going to run faster, and so it's going to get further into the future. But another possibility is that it's not going to get far enough into the future to make a difference, because of this kind of integer increment of moves into the future, where you have to have a full move into the future. And I think Levi is discovering that when you get out to like number 5, like number 6, there's just such a vast increase in the amount of work that has to be done, that getting that next incremental step forward may be just as infeasible with compiled C code as it is with Java.
Yeah, there's interesting dynamics here too, because the pruning that I'm doing with the graph works. I mentioned it works a lot better when the moves are in relatively good order already. But it also works a lot better when the evaluations of the moves are all different. So in my current material count scheme of evaluation, in a particular position, a lot of the next positions are exactly the same as the current position because no piece gets taken. Or even if they do, there might be half of the possible positions that just take a pawn, and so they're all the same from the evaluation perspective. And I actually experimented with adding a little bit of random noise to the evaluation, very small number that doesn't affect the overall magnitude, but at least makes all of the evaluations different. And my evaluation graph search ran a lot faster when I did that. It introduced other problems because it was discarding paths that led to good moves randomly, but uh, a way to kind of counterintuitively, a way to make the search more efficient is to make the evaluation more sophisticated.
Okay. Have you looked at instance populations for each as they grow? How do they grow for each half move? Is there a kind of rough order of magnitude that you've seen?
Yeah, so it depends. It's not consistent because it depends on how many things were pruned. But for
Yeah,
example, at level 3, it evaluates about 37,000 positions. And at level 4, it was evaluating more than 500,000.
right.
And level 5, it actually reduced the new evaluated positions, reduced at level 5.
Because piece count starts to,
Well, as you get into further depths, typically the improvements get less and less. Um, so there's this diminishing return as you get further
Mm.
into the future, and so more things get pruned away because you're more basically as you get deeper. Typically, you find the best move relatively quickly or a good move, and then it gets more and more confident essentially as you get deeper.
Right. Yeah, and also presumably the number of possibilities at the first move are less than they are sort of when you've actually got a slightly more distributed set of pieces because it's not a consistent set. The number of possible plays changes, doesn't it? So it goes for a start. It starts small is the wrong word, but it's smaller than it is in the middle of the game, and then as the piece count goes down, it goes back down again. I guess it's kind of you kind of get some kind of almost a bell curve of possible moves for each half move. I guess it seems
Yeah,
intuitive. I don't know.
yeah, I'm not sure what the curve would actually look like, but you're on the right track. Uh,
Yeah,
and as you get into situations where you're getting into checks and attacks on the king, you can get many situations where you have a whole line of moves that there's only one possible move.
right.
when you're, when a king is being attacked by a knight, there's only one piece that can move and it's got a limited number.
Yeah.
Okay.
So that's the state. I think so. Court's plan of trying to work with MC3020. We're kind of tag teaming on that a little bit. I've got a few more things that I want to implement in my bot, but as Court mentioned earlier, it already beats me all the time, and so I
And
feel
that's a milestone that, that's something that I want to be able to say at the conference that, even xtUML modeling with a simple model compiler and a little bit of compute horsepower, and you got a pretty smart um, chess program.
yeah. So yeah, and so I feel like I've accomplished what I've wanted to accomplish, and I've made something good enough that it's relatively smart, and I can see the differences when I make changes. So I've got a few more things, but here pretty soon, I'm going to pivot more into focusing away from my implementation and focusing more on how can we set up structures to test these different implementations against one another. Even ideas of potentially running a test where you run it all night and have 100 games against one another, and
Have some statistics.
yeah, have some statistics about how often does this bot win and certain things. So um, yeah, that's kind of where I'm moving. Colin, have you opened things up since you returned?
Only today, and yeah, I haven't got past the huge long list of errors in Bridgepoint, so something's not happy. So could do with a sort of one-to-one with you, I think, sharing
Yeah,
the screen as we can work it out.
yeah, maybe we can set something up. I was talking to Court about that yesterday, and I'm suspicious that there's something wrong in your environment that's not directly related,
Okay. Could well be.
because there's just so many different things, not even necessarily Bridgepoint related, that seem to be
Yeah,
going sideways.
could even be. I have to check so JDKs and things like that. There might be all sorts of. Yeah, come on. I'm dusting the cobwebs off all that a bit. So yeah, okay. Well, we can chat about when's a mutually good time.
Okay, yeah, I'll send you a message after.
Okay.
Alistair, do you have an update?
Um, yeah, not as not nearly as impressive as yours, but actually, let me think. You might remember, Levi, I had some strange bug in Sierra that stopped me compiling, and so
Yeah.
I was stuck with verifier. And as you say, once you start looking ahead, it really it's almost unusably slow. But one of the things that bothered me about that is, I mean, I essentially sort of threw up my hands in disgust and said, this brute force approach just doesn't, can't fly, because, I mean, just think concretely. We're coming to, my opponent has made the opening move, and now it's my turn to move. Well, I've got 20 moves I can make, because I've got 8 pawns, which could move 1 step or 2 steps, and I've got 2 knights that could jump out. And so, I look at one of those moves and see what happens. Then I go back and we're going to reevaluate the next move. And guess what? We go through all of those 8 pawns and look at if they were to move 1 step or 2 steps. And I just thought that's ridiculous. So I want to not reevaluate something that I've already looked at that wasn't interesting. So I've backed away quite a bit. And John is kind of I mean, at first too, my thought was, there's no modeling in this. It's just a very deep recursive, computation. So I've changed my strategy a bit, and that's where I'm at now. But by the way, I have to say, I've had some um, issues with Bridgepoint and textual UML that have really, really given me a grief.
So I've seen the issues with compare and with graphics. I haven't
and
seen.
more than graphics, I mean, I've had a whole lot of instability where I looked at textual UML files and the last few lines were missing and things like that, and they wouldn't load. I mean, I've had to nuke and reclone my repo, a dozen times maybe. And I just don't know what's going on. But and the graphics, has been so. I don't know who else is using textual UML and getting away with it, or what am I doing wrong? It's say. Anyway, but back to my current strategy is and again trying to maybe show off some of UML capabilities. I'm doing some sorting I'm building a very simple sort of aggressive approach that says, well, I'm only interested in the moves where the pieces that I have can reach squares that are occupied by my opponent, and then I want to evaluate which of those has the highest score. And then I may add to that the reverse. That is, if on defense, what pieces can my opponent reach? What my pieces are, and what can I do to avoid them? But as I say, I've only just yesterday managed to get back on the rails so that it actually runs. So that's where I'm at.
Okay.
Let me. Were you going to ask my question, or do you want me to ask my question?
I don't know what your question was.
One of the things that I haven't done, and that somebody needs to do before the conference, is, you know, kind of follows on along with what Alistair pointed out, and that we have noted from the very beginning that a good chess program is not really an abstract modeling issue. It's brute force, it's graph theory, it's looking into the future, dealing with 37,000 instances at this level and then 500,000 at the next. And okay, you know, there's some mild interest there, but we need to have an abstract model of strategy. And Alistair, would you say that the direction that you're headed now has a more, you know, a richer class diagram than one that's just focused on, you know,
Yes.
for
Yeah, and I mean, that's what. In fact, I threw up my hands in disgust and went off and did nothing for at least a week. And then I got talking to John, and that was my complaint. I said, "There's nothing here. My original class diagrams had the pieces on a square." That was about it. And so now, yeah, it is a bit richer. I have the notion of open squares and occupied squares and squares that can be reached by moves and moves that are owned by players and whatever. And then I'm able to do some set arithmetic to say, collect all the pieces that belong to my opponent and find the set of squares that they're on, and then find the set of squares that my pieces can reach, and add them together, and I get a set of targets. So,
okay.
So I understand the sentiment, but I also will take slight offense to it because this is my class diagram, and
oh,
I can make it a bit bigger. And I certainly don't have anything in here that you would look at and immediately think this is specific to chess. But this is my class model that I'm using to perform all of this asynchronous evaluation and graph search and pruning and things like that.
okay, no, that's impressive. And you're just operating on if I might say, kind of on a different dimension than I am.
Yes,
I mean,
so
I can share a screen, I think, with my class model. I don't know if I am sharing.
No, not saying anything.
No, I'm not sharing.
we don't.
No.
Let me see if I. What? I don't know how to use this stuff. Oh,
Something's happening.
Here we go.
am I sharing?
Yeah.
So it's pretty simple, but it's chess-like, I suppose.
Yeah, I think this is there's different perspectives that one could take on the challenge, and I think this is something that was what Court has been wanting somebody to do, is model chess even if it's not
If it's not a
particularly useful for a very fast, efficient chess engine. And for me, what I showed, the graph traversal and things like that is the more interesting part of things, and the algorithmic side. And I would say that perhaps xtUML modeling isn't the most efficient way to achieve that, but it's still a very rich way to achieve it that communicates well. And so that's what I've focused on in my implementation. Um, yeah, and so I would so my kind of assertion is that yeah, there is something there to model. It's just not piece types and squares.
Yeah, I have a model as well. I can't show it because my status is my bridge point, but I'd be happy to share it once I can. But I haven't developed any of the algorithm beneath it. I just focused on the abstract model. But it's certainly got many of those elements.
Okay, Colin, I'm glad you're doing that, and that
I just say I haven't gotten there yet, but because right now I'm just picking a move based on the highest value occupied square I can reach. But my thought is he's going to have a state machine for subsequent evaluations, and I can blindly launch events to all of them saying evaluate yourselves, but the ones that I've already evaluated and found nothing interesting will no longer respond to that. And only if something happens to the squares that they are involved with will they put themselves in a position where they will, where they can subsequently reevaluate. But that's still in my mind, not on the. So.
yeah, I love that. That sounds really good.
And of course, John wants these evaluations to run in parallel, which is bothering me a little bit because each move slightly alters ground truth of the chess.
Yeah, it's
parallel evaluations, each of which has to essentially, organize their own ground truth. Anyway, that's where I'm at.
We had discussed, Court and I had discussed parallelism with the evaluation with my implementation as well, and it is not set up to do that at the moment, even though it seems like it should be. It kind of relies on it uses a stack to do the depth first search, and as it goes through, it kind of relies on everything to evaluate in sequence to be able to do the pruning that it does. So
you've got concurrency enough that you can be thinking while the opponent is moving, but
it's a different level of concurrency.
Yeah.
I mean, a different aspect of concurrency, really, rather than yeah. Anyway, this is not nearly as intellectually impressive as Levi's, but it's a step away from just hard computation.
Right.
And I think it's in the spirit of xtUML.
I agree.
So okay. That's all I have to say. Well, again, but I will just say I've had some measure of grief from graphics suddenly changing or files suddenly being corrupted. I don't know what's going on.
Yeah, I'm a bit perplexed about that myself because I haven't experienced any of that.
Huh.
The one thing that I do experience regularly that I could potentially get used to and not consider for other people is when I switch branches or do something that makes a large change to the file system at once, oftentimes I get the message that says that something has been corrupted in loading, but I can always close Bridgepoint and open it again after I've switched branches and it loads just fine. So I haven't had any experiences of files getting truncated as they're written or anything where there's things missing. I have encountered some of the same graphics anomalies. Um, I think I haven't analyzed those closely, but I have seen um, graphical files sometimes change a little bit depending on what I'm doing. But for the most part, I haven't run into any issues with corrupted data.
Well, and this is, as painful as it is, this is one of the reasons that we're having the chess challenge, that to get some exposure to the textual xtUML and give people motivation to try to use it, even if they're going to bump into some things. And hopefully we can work through them.
And Alistair, just to confirm, you're not editing the XML files outside of Bridgepoint or in a text editor of any kind, are you?
Only very carefully to repair damage. I managed just to rescue this graphics when I opened it the day before yesterday. This connector had turned into a super type connector, and this one had lost its notion of super type, and so on. I think I sent you a zip of that.
Okay.
So what I found is what you have to do is carefully delete the relationships from the graphics and then go to the semantics file and delete the relationships there and then reconstruct them.
Okay. I would think that have you tried deleting the relationship from the graphics file and then just reconciling graphics?
Well, strange things happened. I mean, one of my classes disappeared until I reconciled the graphics, and then it showed up someplace else. And you know, I don't know what to say except that I've experienced quite a number of problems, and I don't know why. It may be that I'm trying to get in the habit of committing more often. So maybe it's the changes I'm making on a commit, but why should eGit care about that?
Yeah, I don't think that I mean that helps you in situations where you may lose less work, but
Yeah.
I think the act of committing makes Bridgepoint any less likely to fail. Okay, well, the most detailed notes that you can take on the issues that you face is going to help the most.
Okay.
So I think that's all I can say at the moment.
I mean, as I think maybe you saw at least one of my graphics ones where a subtype disappeared and the connector that should have gone to it routed itself back to the super type. Well, that's not something I could do in Bridgepoint. So I don't know how it happened.
Yeah.
So. Okay, well, my intention is to now start adding a bit of look ahead to this, and I hope, be able to eliminate redundant reevaluations of moves. Like I say, I don't ever want to look at rook's pawn to one step and then two steps more than once.
Right. Okay.
unless somebody has come within range of him.
Of course.
Which means that I know what the last opponent's move did. I know what squares are affected, And so any piece which has moves involving those squares, we need to reconsider whether those moves are now worthy of reevaluation. So yes, of course, I guess I'm trying to some way model strategy rather than just brute force.
Thank you.
All right, any other comments or topics for today? Okay, we can end now, and I'll send out the video link for anybody that missed after sometime later today. So it's good talking to
Okay.
you.
Okay.
Okay.
Bye-bye.
I'll talk to you soon. Bye bye.
Yes. Okay, bye-bye.
Okay.